What is the meaning of a transpose? Transpose means interchange of rows into columns and columns into rows. Define, so its definition is that let a matrix whose elements are a I j and order is m cross n, and its transpose is that at is equal to a j I, order is reverse n cross m. So we can see the example of a transpose then. So a is equal to, first of all, rows we count 2, 3, 4, minus 1, 0, 5, and order is that 3 cross 2. Then we can interchange rows into columns. So we can say that the transpose of a matrix is that A3 is equal to 2, 3 is a row, and we can change into column 2, 3. 4 minus 1 is a row and 4 minus 1 is a column. 0, 5 is a row and we can change 0, 5 into column, and order is also reverse 3, 2, and it's that 2 cross 3 is a transpose of a matrix A. So easily define the theorem is that the matrix A and B are conformable for A plus B and AB. Then we can see the first theorem is that A plus B whole cut transpose is equal to A transpose plus B transpose. Let a matrix A whose elements are A I J and M cross N is order, and B matrix is that B I J and its order is M cross N. So we can write left hand side A plus B का transpose is equal to A elements with order plus B elements, B के elements Bij M cross N. So we add the elements of the two matrix easily because both matrix have same order. If two matrix have same order, then we can add. If two matrices are not have same order, then we cannot add. So we can easily add because they have same order, Aij plus Bij with order M cross N whole cut transpose. So left hand side is that we can take transpose Ij into Ji. We can convert rows into columns and columns into rows. Left hand side, and we can take and solve the right hand side of the theorem. A transpose is equal to A elements in a bracket of whole transpose Aij M cross N, then its matrix is transpose is that Aj N cross M, and B elements Bij M cross N whole transpose is equal to after transpose Bji N cross M, then they are same after adding. So Aji plus Bji N cross M is the right hand side and left hand side is also same. So we can say that A plus B transpose is equal to A transpose plus B transpose. Second theorem is a simple. A transpose is equal A transpose whole transpose is equal to A. Let A elements let A is a matrix of elements Aij M cross N. A transpose is equal to Aji N cross M, and A transpose whole transpose लेंगे into also its change into uh, condition. It's also change into its original condition Aij M cross N. A is equal to A transpose is equal to A. So we can say that A is equal to Aij M cross N is equal to a symbol, and we can also write the third theorem is that A whole cut transpose is equal to K A cut transpose are equal. Then we can say that K belongs to F. F is a field. Let A is a matrix is equal to Aij M cross N of order that. So ka ka transpose is equal to k into aij m cross n whole transpose. We can see the fourth theorem of multiplication. This theorem is very important for examination. And the theorem is that a b transpose is equal to b transpose a transpose. It's very important for examination and the paper of the board. Further, let A is a matrix and B is also a matrix whose elements are Aij. Order is that m cross n. So we take order m cross n and n cross p. And the necessary condition for multiplication of two matrices is that the number of columns in our first matrix is equal to the number of rows in the second matrix, such that in B, so we can take n number of columns in matrix A and n number of rows in matrix B, so we can easily multiply of two matrix A B ka transpose is equal to Aij m cross n and Bij n cross p. N is the number of columns and n are rows. We can multiply and whole transpose. After multiplication we can take result sigma lambda from 1 to n ai lambda, where lambda is vary because its columns are changed, and b lambda j lambda satisfy the number of rows because the number of rows are changed with order m cross p and whole cut transpose. Now we can take transpose of the matrix AB, the multiplication sigma lambda from 1 to n a lambda j. We can change rows into columns and columns into rows. Lambda firstly write and secondly write j. So b I lambda m p cross m, because transpose m cross p change into p cross m, rows into column and column into rows. So this is the left hand side of the theorem, and the right hand side we can now solve. B transpose is equal to Bij n cross p is its elements. Then we can take transpose of the matrix B, Bji p cross n, change also order. So A का transpose is equal to Aij m cross n. Then after transpose of the matrix is that Aj n cross m. B का transpose, A का transpose is equal to Bji, where we can solve Bji p cross n multiply Aj n cross m. So after multiplication where also vary of matrix, where also vary lambda from 1 to n, bi lambda, where number of columns are also changed, and the matrix A in which the number of rows are changed, bi lambda b lambda j p cross m, क्योंकि because n are same and p cross m. So after multiplication sigma lambda from 1 to n a lambda j b I lambda p cross m, simply you can say that this is the left hand side and right hand side are equal, so we can say that left hand side is equal to right hand side. Please like my video and subscribe my channel. Thanks for watching.